Hello there. Thank you for clicking on this video, maybe from the exciting lesson on this topic where one slide got dragged to the end of the presentation. So you might be recovering from that. Hopefully that is not the case. We will not have that kind of surprise here. This is our practice set on degree, leading coefficient, and end behavior. Please like and subscribe if you find this video helpful. Drop a comment or question to engage, and check out the many other videos and lessons on the channel. So as always, pause the video to work these problems on your own and then come back to check your work. Okay, so these first four shouldn't take a long time. These are basically vocabulary. This is what we would call a low-level skill. I always tell my students when I've taught this, if you're getting these questions wrong, it is not because they are too advanced and complicated. It's because you're not practicing to make sure that you're comfortable with these words. So the degree is simply the highest exponent. Everybody is capable of looking at like these expressions and identifying like what is the highest exponent. So we'll do the first one in red here. The highest exponent is 2. And so make sure when you're answering that, like I'm writing DEG for degree and specifying 2, don't just write like the number 2. So if you're looking at your work and you just have like numbers there, remember that if you are submitting the work for grading, so whether your teacher assigned this video or if you're doing this for, you're going to do a similar assignment for your teacher, that you would want to make it user friendly. I say, like, make sure that the teacher knows what you're looking at. And the leading coefficient is the coefficient that goes with the degree. So the leading coefficient in this case is 3. Next one, scanning the next one for the highest exponent, and I see the highest exponent is a 3, so the degree is 3. And the leading coefficient here, we want to remember if you don't see the leading coefficient, I kind of blocked out my negative there, I didn't want to do that. Then the leading coefficient is a 1, so that is -1 x to the third. So our leading coefficient there is -1. Most common mistake there is to say probably x. I've had students say 0, and I've had students say there is no leading coefficient. So just kind of like abandoning all hope on the problem altogether. Now, this third one is not in standard form. So you want to just make sure that's one of those quick little things of making sure that we're not saying that the definition of degree is the exponent the furthest to the left. Is it often the exponent furthest to the left? Yes, because that's where standard form will put it, and we're in standard form a lot, but that is not the definition of it. The definition is the highest exponent. And so in this case, the highest exponent is a 3, so that is degree 3. And when you're pulling the leading coefficient, you want to remember that that subtraction could be rewritten as plus negative. I actually just went over this with a student earlier this week, talking about how when you see a subtraction, that the subtraction is a negative and it's attached to the thing that you are subtracting. This kind of goes all the way back to whenever you were first introduced to negative numbers and operating with them. So in this case, the leading coefficient is -2. Last but not least, this one is also not in standard form. And so we got to go through and find the highest exponent, which appears to be a 5. And the leading coefficient, this one kind of combines the best of both worlds. That's going to be a -1. And all of those problems took me less than 4 minutes to do. And that was with some exposition and talking, just kind of drawing your attention to some things there. So, I mean, it might take you a little bit longer, but these should be very, very fast to do. All right, so now we get to state the end behavior using both informal and formal verbiage. So what would be the casual way of saying it, and then what would be the more formal way? So for number 5, we are going to start by identifying the degree and the leading coefficient. So looking at this, I see that the degree is 3, and I see that the leading coefficient is also 3. Now, what's important about that is that the degree is odd and the leading coefficient is positive. It's not as important to like what actually the degree is. Like it could be 3, 5. Those are all going to have the same end behavior. And it's not really important with the leading coefficient exactly what it is. What's important for the end behavior is that it's positive. Now, which degree it is and what the leading coefficient actually is, will that change the shape of the graph somehow? Yes, but it does not change the end behavior. Now, when I see odd, okay, I think in my head, this is like a line, okay? And this would be a line with positive slope. So we'd be looking like that, okay? A line with positive slope. And so I could answer this, the left is going down and the right is going up. In my more formal notation, to say left, I would say as x approaches negative infinity. And then to say down, I would say f of x approaches negative infinity. To get the right, I would say as x approaches infinity. And to say up, we would say f of x approaches infinity, or you could say y. I would say y is probably just as common. All right, for this next one, we have, this looks like degree 1, okay? And a leading coefficient of -1. And what's important is that that is odd and this is negative. Now, over in the one that I just did, I kind of said, oh, degree 3 is odd. That's going to make it like a line. This one actually is a line, okay? When you have degree 1, that actually is a line. And that negative means it's a line with negative slope. So we're looking like that kind of template, in which case the left is going up and the right is going down. In our more formal notation, we'd say as x approaches negative infinity, f of x is approaching infinity. So that's our fancy way of saying left and our fancy way of saying up. As x approaches infinity, fancy way of saying right, f of x approaches negative infinity. Fancy way of saying down. Those two problems took me in the ballpark of 3 minutes. So just kind of keeping an eye on the time. And again, I'm doing that with explanation and writing a lot of stuff that you wouldn't necessarily need to write. Okay, next 3. The next one is not in standard form. So actually the next 2 are not in standard form. So we want to make sure that we catch that. In number 7, my degree is 2 and my leading coefficient is -5. And what's important about the 2 is that it's even, and what's important about the -5 is that it's negative. Now, normally I would say, hey, if it's even, it's going to be like a parabola, except that this is degree 2, so it actually is a parabola. It's not like a parabola, it is a parabola. And the negative means that your parabola is flipped over. And so that's what we're looking at. So it'll be left is down, right is down, and in our more formal notation, as x approaches negative infinity, f of x approaches negative infinity, so left and down. As x, I didn't put the x in there, let's get the x in there, there we go, approaches infinity, because we want to go to the right this time. F of x still approaching negative infinity. Number 8. Okay, so number 8, also not in standard form. So that is degree 4. Gotta hunt for the degree there. And the leading coefficient, remember, if you don't see one, it is a 1. And what's important about that is that the degree is even and the leading coefficient is positive. So this is like a parabola. Now, this one is not a parabola because it is degree 4, but in terms of its end behavior, it is going to be like a parabola. The positive means your parabola is not flipped. So we're looking at that situation right there, in which the left is going up and the right is also going up. So our formal way of saying that, as x approaches negative infinity, f of x approaches infinity. So left and up. As x approaches infinity, that's my right, f of x is approaching infinity. Now, you might have noticed that those first 4 covered all 4 of the things that could happen. So now we got to think, what is this last one? What did she do? Oh, the excitement, right? Am I wrong? All right, so this one is in standard form, and the degree is right here. So this is degree 2. And my leading coefficient is 1/2. So we're getting a little fraction in there. And what's important is that the degree is even and the leading coefficient is positive. Now, as with number 7, this one actually is a parabola, and it's got a positive leading coefficient, which means it is not flipped over. So we are looking at that situation, which is going to give us the same answer as the last one in terms of end behavior. The left is pointing up, the right is pointing up, and so we have, as x approaches negative infinity, f of x approaches infinity, and as x approaches infinity, f of x approaches infinity. So there we go. Yay. With the end behavior. And now 10, I think, is where this can get useful. All right. So 10 is a multiple choice question. It says, which of the following could be the function generating the function below? Not the great phrasing, the function generating the function graph below. I think the function, we have a function as an equation and a function as a graph. And I overused the word function. I'm on my game. We just finished our second full week of school, and I'm exhausted. So I'm going to just claim like exhaustion. All right, so this is where it would be so much easier to know your rules for end behavior, okay? Because if you needed to type in all of those answer choices into Desmos or a graphing calculator, that is going to be very inefficient. In fact, it's going to be inefficient to even type one of them in. So what I'm going to do for this one, I'm going to notice how long it takes me to do it, okay? 53 seconds on the timer, is I notice that the left is pointing up and the right is pointing down. And so it's like that. Okay. That's now the graph we have has like a little bump in it, but in terms of the end behavior, it looks like that. So what I know is that's like a line. So I'm going to look for odd degree. And because it is tilted down, that's like having a negative slope. So I'm going to be looking for a negative leading coefficient. So now I know what I'm looking for. I'm looking for something with odd degree and negative leading coefficient. So finding all the degrees, I got 3, 5, 6, and 4, not picking those. And then looking at my leading coefficients, I want the negative. So the answer choice is B. And that is, it took me 1 minute. Okay, because it's on the timer on the slide is 1:53. So that took me 1 minute with an explanation in it. If I were trying to type that, and I'm pretty good at typing on Desmos, so if I were trying to type on Desmos, it would take me longer than a minute to get there. And that's why even with the introduction of graphing utilities, this is still a valuable skill to have. This can save you a lot of time if you know this piece of information. All right, that's it. So don't forget to like and subscribe for more math help. Ask me a question or make a request by commenting below, and check out the many other videos and playlists that we have on the channel. I'm always adding new content, so if there's something you'd like to see and you can't find it, please send me a message, drop a comment, let me know. Hope to see you in a future video.